This is Kayla Ternaj,
Victor Flores.
And Jesus Salazar.
and this is our Stats 1200 final project.
Okay, so our prompt is pretty much about driving under the influence of alcohol, or DUI for short. DUIs are a serious offense, and the following data gives the ages of a random sample of 50 drivers arrested while under the influence of alcohol. This is the data that was provided.
Part A of the project involves creating a stem and leaf display based off the data, and to create a leaf plot, you take the first digit of the data sequence and list them in ascending order. For the leaf, next take the last digit of the data sequence and match them with their respective first digit.
For part B, we had to make a frequency table. In making the frequency table, we took 50 data values and distributed them equally into 7 classes. The upper limit is the highest data value of the class, while the lowest data value is the lower class limit. The class width is the difference between the consecutive lower class limits. The frequencies are tallied by counting the amount of numbers between the upper and lower boundaries, and the relative frequency is calculated by dividing the frequency by the sum of all the frequencies.
Part C involves making the histogram, which represents the DUI age frequency. The vertical axis is the frequency, and the age range is the horizontal axis. Firstly, to compute the class width, you subtract the largest data value from the smallest data value, and then divide by the number of desired classes. Secondly, create classes by starting from the lowest class value and add the class width to it. There should not be overlapping classes. Finally, find the relative frequency by dividing the frequency by the total. Part D involves creating a relative frequency histogram, which represents the DUI age frequency with the DUI proportion as the vertical axis and the age range as the horizontal axis.
For part F, we created an ogive. The ogive demonstrates the cumulative frequency at each of the upper limits. As you move along the x-axis, you are able to see each of the upper class limits. At each of the upper class limits, there's a point that shows the percentage of the random sample size that has received a DUI. That percentage is cumulative among all ages between that upper limit and the lowest lower limit. For part G, we discussed how the data might be used to price auto insurance at different age groups. Based on the data provided, we are able to see the frequency of DUIs for each age range. 44% of the DUIs were given to drivers between the ages of 23 and 36. After the age of 36, the frequency begins to decrease. Auto insurance agencies can use this information to help determine insurance costs depending on the age of drivers. Insurance rates would be higher for drivers under the age of 36 due to the higher risk of them receiving a DUI. However, rates would then begin to decline after the age of 36.
For part H, we had to look for the mean, the variance, and the standard deviation. To obtain the mean is by adding all the data values together and dividing by the total number of values. To get the variance, you need a table that shows each data value in one column, subtracting the mean from each data value in the second column, and squaring the difference from the second column in the third column. Then add each of the squared numbers together and divide by one less than the total number of values to obtain the standard deviation, square root the data value from the variance. For part I, we had to take simple random samples, and we created 8 groups of 5, in total 40 simple random samples, and found the mean for each group. To find the mean, add up all the data values from one group and divide by the number of values being added, in this case 5. For part J, we had to determine if the sampling distribution was a normal distribution, and for our case, we can assume that the sampling distribution will be a normal distribution because the mean for the simple random samples were pretty evenly distributed. The distribution of 40 simple random samples ranged from 25.6 to 40.4.
This will conclude our presentation.